In the shadows of complexity, we find clarity. This is NebTech. Welcome to my channel. I've spent many years watching programmers make the same mistakes. They write code that lets impossible things happen. Then impossible things happen. Then they stay up all night fixing production. The best programmers I know have a particular way of thinking. They don't ask, how do I make this work? They ask, how do I make it impossible for this to break? That's the difference between a programmer and an engineer. The $50,000 bug last year, a client of mine processed financial reports that directly affected customer billing. A report followed a simple workflow: drafted, submitted for review, then either rejected back to draft or published to customers. Standard stuff. One day, their junior developer accidentally published a draft report directly, bypassing review. The error wasn't caught for 3 days. By then, thousands of customers had been incorrectly billed. The cleanup cost them around $50,000 in refunds, emergency developer time, and customer service hours. The bug itself, laughably simple. The developer called publish report on a draft instead of submit for review. Nothing prevented this. The code happily published the unreviewed report because why wouldn't it? They hadn't told it not to. Paths that shouldn't exist. When I audited their codebase after the incident, I realized their entire approach was flawed. They had built a system with more possible states than valid states. They were checking for invalid transitions at runtime, but they were checking inconsistently. And one missed check had cost them dearly. What they needed was a system where invalid states were not just detected, but unrepresentable, where the compiler itself would prevent impossible transitions. This is where Rust and Go diverge philosophically. And it's not just an academic difference, it has real financial consequences. The Rust solution. In Rust, you've probably seen this example. The idea is basically, we can make illegal state transitions actually impossible to express in code. Let's start by breaking down the Rust module. Inside the reports module, we define 3 structs, each representing a different stage in the life cycle of a report: draft report, unpublished report, and published report. Each struct has a private content field, and none of them share methods between each other directly. This is intentional. It creates a strong, enforced state machine at the type level. Here's how the draft behaves. The new method initializes a draft. Edit returns a modified version of the draft. Since it takes ownership self, any previous instance is invalidated. Submit transitions the report from draft report to unpublished report. This ownership-based transition means you can't accidentally reuse or mutate previous states. The unpublished report can either be rejected, going back to a draft, published, becoming a published report. Again, both transitions consume the unpublished report. Once published, a report is immutable. You can read its content, but that's it. No edit, no rollback, no cheating. Now, switching to Go. Let's see how Go handles the same logic. Go structs and methods. These are just basic structs, no enforced transitions here. We can mutate the draft in place. This means old references still work. Submit returns a new unpublished report, but it doesn't invalidate the draft. Now, let's walk through the Rust main function. We bring in all the report types and start by creating a draft. Then we edit it. We even illustrate a failed attempt to reuse the moved draft. Rust enforces linear transitions. You can't go back in time or reuse consumed state. At the end, we print the final content. Any invalid access or creation is simply not allowed by the compiler. Now let's look at the Go main function. Here comes the trouble. Draft edit. Wait, I'm editing a submitted draft? That's right, we're editing the draft even after submission. Totally valid in Go. And here we bypass the entire review process. No compiler errors, no state guardrails. You get both proper and improper outputs. The compiler lets you shoot yourself in the foot. Rust enforces transitions through ownership and strict typing. You can't go from draft to published without passing through the proper steps. Invalid states, the compiler blocks them at compile time. Go, on the other hand, relies on convention. You can follow the correct process or ignore it completely. The compiler won't help you catch logical mistakes. You need discipline and good reviews. What begins in shadows ends in understanding. You've been watching NebTech. If you found value here, please consider liking and subscribing. It means a lot and helps the channel grow.